Okay, moving on to the next rule, the quotient rule. So very similar to the product rule in terms of the formula. When you have the derivative of the quotient of two functions, or f over g, the numerator looks very similar to the product rule, except that we have a negative sign. And in this negative sign, we see that the order matters in terms of taking the derivative of the numerator first. With the product rule, it didn't matter which derivative you took first, but in this case, let's take the derivative of that numerator first. The denominator of the derivative is the original denominator all squared. I would say from my experience that it's almost always likely that you should not expand your denominator to the final answer. However, you should simplify the numerator if you are asked to do so. I'll do three examples. The first example, I will simplify the numerator, but then the subsequent two examples, I will not simplify the numerator, as that part becomes more algebra than it does become calculus. Let's take a look. Okay, first example, we have here the 2x plus 1 over 3x plus 5. So the ratio of two linear functions. So let's get that derivative down. So what you want to do, I like to make a little template here. So like that, and that should be a minus sign. Okay, there we go. As you might notice, I do all these videos in one take just so that it's more exciting and more practice for my part to be on my toes. Anyway, let's take a look here. We're going to do the derivative of the numerator, which is 2. Then we're going to hold the denominator, that's 3x plus 5. Then we'll hold the numerator, and then do the derivative of the denominator. So that's a 3. And then you leave the denominator as is and just square that. So there you go. And we'll just simplify the numerator now. So we'll have here a 6x plus 10 minus 3, 6x, sorry, and then minus 3. So what I'm doing here is 3. This is often the students ask me this in class. That's negative 3 times this. So negative 3 times 2x plus 1 is negative 6x minus 3. Notice the 6x is canceled. So you just get 7 on the numerator. Okay, there you go. Now, in the subsequent examples, I will not simplify the numerator. I'll just write down the rule and leave it as is. But it's important that you pay attention to how your teacher asks questions on a test. Let's take a look at this example here. So let's write down the template. Perhaps this time, because I'm not simplifying the numerator, I can just copy and paste that for the third question. Here we go. The derivative of the numerator is 2x. Then you leave the bottom alone, so 2x minus 3. Then you copy the numerator. And then you take the derivative of the denominator, which is just 2, over the original denominator all squared. There you go. Now, you can simplify this, but I will not do that in this video. And you can obviously use math software to double check your work there. Lots of math software on the internet available for checking your derivatives. Okay, one more example. In this case, just another quadratic on the numerator. There you go. So maybe this pasting will work here. There you go. Ooh, that's a little bit spicy. Let's get that font down to something a bit more similar to the first line. There we go. So the derivative of the numerator is 22x minus 2. Then you just copy the bottom. Now, I like to be a little bit creative here, so I'm just going to copy the bottom twice. There you go. And then we can take the numerator. Lots of copying. Look at that. The majority of this answer is copying. I laugh with my students telling them that most of their answers in these questions with the product and quotient rule comes down to just copying. So in fact, let me just highlight the derivative of the local numerator and denominator. You'll see here the stuff in red is really derivatives of the original components of the original function. And then the stuff in yellow is copying. So there you go. 3/5 of this answer is copying. Of course, you should know the template as well. Hopefully that was easy to follow, and I look forward to the next video.